So there are a number of things that one must have for evolution to occur. There's my thing. We need adaptation and we need natural selection, not artificial selection, natural selection. So what's the difference between artificial and natural selection? Artificial is where I choose. I am choosing the traits that I want to perpetuate, okay? Think of it like, a dog, okay? I want that trait of a dog and I like, that trait of a dog, I'm going to get those two to come together and I'm going to get their offspring, and that's artificial selection. Natural selection is seeing how the organism exists in the real world and how it adapts to that real world, right? That's truly the mechanism that stirs the pot for natural selection, for evolution. For this to occur, we're going to need something that can be passed on from one generation to the next, and we know that as the G word, genes. A huge number of offspring must be produced. And by that, I mean we have enough resources. That's all that means, okay? The chances of getting a trait to perpetuate for a much longer period of time, obviously you need food. If we don't have food, I can't make energy, I'm not going to survive, okay? I've mentioned it a few different times, but those individuals that have these favorable traits survive. They are desirable, okay? They're able to adapt to the environment that is, or to a change in the environment that may come. And when they survive, they're able to get more resources. They get more resources, they have more energy. They have more energy now, they can have sex. They can pass those genes on to the next generation. And when you start to add generation to generation to generation, you're hoping that it's that favorable trait that starts to multiply through the various generations, and it allows them to easily adapt to that environment. That's basically what we need. How do we see that? Well, that's biogeography, fossils, that's all that stuff. Okay, and we'll talk about that here in a little bit. Maybe tomorrow. Tomorrow. What the hell is today? Next week. Okay. And this is just kind of what I've been saying over and over and over again. It's all about surviving and advancing, just like the NCAA tournament. Okay. It's all about survive and advance. But the biggest thing, okay, I need variation. Okay. I need variation. I need variation. Where does that variation exist? That variation exists in our gene pool. I can just have one little misread, right? Not common, but I can have a little bitty misread. And that misread may code for an entirely different protein, which produces a various different structure. Maybe a little bit more thicker skin, maybe darker skin, maybe lighter skin, maybe hair. But it's that one little adaptation, that one little variation that can potentially give that individual a better chance of surviving the environment. If you live on the equator, would you want really light skin or really, really dark skin? You want really, really dark skin. So if you have an albino, or if you have very light colored individuals who populate around that equator, the chances of their survival are going to be very low. Be more prone for cancer. And that's never an adaptation that usually wins out in the end. We need a variation in the gene pool, so we can only have a change in genes, okay? Like Lamarck, I can't just stretch out my neck and elongate my neck a little bit and pass that on. That's something that's structure that I've altered, not my genes. So it has to be something that can be passed on. It has to be genetic in nature. I can't just pass on a trait that I acquire, okay? Like elongating my neck, which certain tribes do that. These variations I keep talking about, I always think of them, or I talk of them as good, and they're potentially not good, okay? They can be bad. There's no direction. There's no anticipation for what in the hell is going to happen in the future. So these adaptations that can happen can be detrimental. If they are detrimental, obviously they're not going to survive. They're not going to pass on their genes and yada, yada, yada. That trait doesn't survive, at least in big numbers. Variations in the coloration of a shell. Okay. Those that live on darker trees and have darker shell colors, they're going to survive. They're not going to get plucked off. The bird's going to have a much more difficult time seeing them. They perpetuate increase in numbers. They're going to be the only individuals that are going to be populating in large numbers. Whereas the lighter color shells are getting picked off on a dark tree. They're going to be fewer in numbers. So there's going to be fewer of those genes within the gene pool. They still exist. There's just fewer of them. These guys have a better advantage on a dark tree to survive. They ain't going to be seen. It's these variations that drive evolution, and it's these variations that really no one really considered a whole hell of a lot. But understanding genetics and mutations and chromosomal changes that occur, I mean, that was not something that was known at the time. So it really wasn't something that was discussed about very much. Oh, it's a variation, it's an imperfection, whatever. Why does that exist? How does that exist? That should have been the question that they were asking. It's these small little changes, these small little adaptations / variations that are crucial for Darwin. And it's funny because he comes up with this theory and it's pretty damn spot on, but he had no idea about biochemistry. He had no idea about genetics. And he came up with all of these concepts that are actually pretty true. He actually got pretty damn lucky when you look at it with coming up with his theories of evolution and what was driving this thing. There was so much that was never known at the time, or he didn't understand. And to come up with this theory, I mean, it's pretty remarkable when you think about it. So here's the word that I've been using here, talking about fitness. And what is fitness? It's just reproductive success. That's it. Okay. The most fit individuals are able to capture the most resources, have a larger brood, and that is a larger number of my genes into the next generation. Okay. And that's what it's all about. Okay. That's what it's all about. There's artificial selection. Okay. Where you choose. And that's not what natural selection is. Okay. That is not what natural selection is. What determines fitness? What determines my reproductive success? Gosh dang, guys, that changes, man. That changes. Okay. Reproductive success up in something that's really cold, probably a lot greater fat content on the body would be a hell of a lot of fitness. Someone who is a little bit more fatter may not be able to adapt and have a lot of excess weight, may not be able to run and adapt in an environment that you need to run around more and do a lot more hunting. And it's really, really hot. You don't need all that extra weight. So that fitness would not be the same fitness for that environment. So it just depends on the population, the environment, the prey, all that stuff. Okay. So what determines fitness isn't always the same. What is the evidence to support the hypothesis that is the scientific theory of evolution? That's right here. Seven different things. There's these 7 different things that in the past has made a good short answer question. I don't know what I'm going to do this time. Okay. I still think it makes a good short answer question. So I'll probably still ask it as that. A lot of moving parts. Oh my God, I could have this thing as big as I want. Okay. Oh, I'm sure you would just love that. Let's stop here because I'm not going to get through all of it here. Okay. So we'll look at the evidence for common descent, the evidence for evolutionary change, the evidence for the scientific theory of evolution. We'll look at that on Monday.